Hello everyone, I'm here today to go over solving inequalities. This is lesson 1.5. There's 22 questions in this problem, so this will probably be a couple videos. I'm hoping to get through this lesson today, but if I do not, I will get the other one loaded soon. Okay. X is greater than or equal to -9. I feel like we need, we need to talk about this real quick. Okay. So, okay. So if I have X is greater than 9, X is less than, we'll say 8, X is greater than or equal to 7, and X is less than or equal to 6. These are our 4 different inequalities right here. We have greater than, less than, greater than or equal to, less than or equal to. This lesson they're going to have us write inequalities, then interval notation, and graphing. So I want to show y'all each of these real quick. So if I was to graph this one right here, these graphs are going to be ugly, heads up. So 8, 9, 10. If it is greater than and not equal to, we use a parenthesis. So this would be a parenthesis, and it faces whichever way this arrow is going as long as X is first. I might add that down here. So if X is first, greater than, we're going the same way that arrow points. Make sure your parenthesis or bracket opens that way and it goes that way. So then this is our graph. Our interval notation is going to be, this goes from 9 to positive infinity. We don't know when this is stopping. It goes all the way up. X is less than 8. 7, 8, 9. Since it's less than and X is first, it matches this one. At 8, we're going to open it up toward that way. I'm trying to get it on the line. It's the collaboration stuff. But y'all won't have to draw so much. You're going to have to click the correct ones, I'm pretty sure. So it goes the same way this arrow points down the number line. It's at 8, but it's not equal to 8, so it's a parenthesis, and it goes this way. So when we go to do interval notation, it's always least to greatest. So we're coming all the way from negative infinity because we don't know where this starts. So negative infinity to 8. Now, this is where things change. So we have X is greater than or equal to 7. So we'll do 6, 7, 8. But greater than, it's still facing this one, so we're going to have it going this way. Since X is first, we just take this arrow and bring it right over. Now, here's the change. Since it's equal to, we use a bracket. If it's equal to something, you use a bracket. If it's not equal to, you use a parenthesis. And then we go all the way to our arrow. Now when you do your interval notation, once again, this bracket means it's equal to. So we're going to have bracket 7 to positive infinity because it's going up the number line. Okay, last one. 5, 6, 7. So our arrow is less than. It's going to go, okay, down the number line. And then 6, but it's equal to, if there's a line under it, think that you have to have that line. If there's not a line, you're curving because it's parentheses. But since it's a bracket, it's equal to. Since it's equal to, it's a bracket. And then we're going to connect our arrow to our bracket. And so this one, least to greatest, so our least is going to be negative infinity to 6. Okay. Now that we've covered this, let's go ahead and pull our graph back up. So we have greater than or equal to -9. X is greater than or equal to -9. So I know that we have to have a bracket, so it cannot be B or C because those would just be less than or greater than. Now, greater than or equal to -9, this one is less than or equal to -9. This one's our greater than. Oh, here we have a closed interval. What this means is that x is between these two values. Where if it goes to -infinity and it goes to positive infinity, it's just x is greater than or x is less than. Whenever we have this, though, it's closed. Part 1 of 2. Okay. The first thing it asks for is interval notation. So whenever it's interval notation, we take whatever this is and whatever it has. If it has a bracket, if it has a parenthesis. So it's bracket, -1, 2, and this one can be different. So if it was a parenthesis, we'd do a parenthesis, but it's a bracket as well. -1 to 3 is our interval notation. Okay. Now then it wants us to use an inequality involving x to describe the graph. So our x is between these two values, and that's exactly how we're going to write it. I'm going to have -1, x, and 3. Now our inequalities are less than or greater than signs. Whenever it is a closed one, it's always going to be less thans. Now ours also is equal to because these are brackets. So -1 is less than or equal to x, which is less than or equal to 3. So -1 is less than or equal to, x less than equal 3. So I did the less than sign on my keyboard and the equal to sign, and it changed it. If you don't do that, it should pop up right here, those signs. Okay. This one goes from -6 with a bracket all the way to positive infinity. So the graph represents the interval. Type your answer in interval notation. So our interval notation is the bracket, -6, and it goes all the way to positive infinity. That one I am going to have to use this. That infinity sign right there. Okay. So we have bracket, -6 to, I need to get a keyboard in here. And whenever you have a parenthesis, it has to be, whenever you have an infinity, it has to be a parenthesis. Do not put a bracket with an infinity sign because that means it's equal to infinity, and we do not know what infinity is, so we cannot be equal to infinity. I should have said that on my little sheet. Okay, and then our inequality here is going to be x. It goes this way, so greater than, brackets, equal to, -6. X is greater than, equal to, -6. I probably did one of each of these problems, like each sign. Okay, this one, they want it in interval notation first, so we're going to pull it straight from the graph. Right here we have bracket, -8. Over here we have 2 with a parenthesis. And that's exactly what you put there. So bracket, because they had a bracket, and that means it's equal to, and then 2, and 2 had a parenthesis, so we're going to use a 2. Okay, next part, they're going to want this as the inequality, so I'm going to have x is between these. Whenever x is between them, they're both less thans. This one has a bracket, so it's equal to. So -8 is less than or equal to x, which is less than 2. Let me put this. Negative 8 less than or equal to x less than 2. Enter. Okay, now then we're going to do this reverse. Use interval notation to express the inequality. What is the resulting interval? So we're going to take it straight from this. And since it's here, I'll rewrite it. Because that's tiny. So less than or equal to means bracket, 0. This one is less than or equal to as well, so 5, bracket. Trying to think if there's something I need to add right there. Bracket, 0, comma, 5, bracket. Not a brace, bracket. Remember that equal to's mean brackets. That's the biggest thing. So I know that both of mine are going to have brackets. This has parentheses. No. Parenthesis bracket. No. Bracket, bracket. And this one goes to infinity. So okay, next one we have negative 9 is less than or equal to x, which is less than 5. First thing they want is interval notation, so since it has an equal to's mean brackets. This 5 does not have an equal to, so it is a parenthesis. Bracket. Okay, our graph, we're going to have a bracket with our negative 9. That one has a parenthesis. This one has a bracket, and this one has a bracket. Now our 5 has a parenthesis. This one has 2 brackets. This one has the bracket and our parenthesis that we need. Whatever's with it is what you keep with it. All right, the inequality represents the interval. This is just x is greater than or equal to 0. So greater than means we're going to go to positive infinity up the number line. Equal to means bracket. And we're going to positive infinity. Infinity always has parentheses. So bracket 0 to infinity with a parenthesis. So bracket 0 to infinity with a parenthesis. Okay. Then we're going to find that graph. Parenthesis, bracket, bracket, parenthesis. So we have, these two have brackets. This one goes to negative infinity. This one goes to positive infinity. X is less than 1. So since it's less than 1 is going to start at negative infinity. Infinity always has parentheses. And it's going to go to 1. And since this one is not equal to, it's a parenthesis. So negative infinity to 1, all parentheses because it is not equal to. Okay, we're looking for a graph coming from negative infinity, these two, and this one has a parenthesis, this one has a bracket. Our graph was not equal to, so it's not equal to. Okay, now that it's changing it again. So we have interval notations, what they give us, and they're wanting us to change it to the inequality first, so we're putting x in this. So x is going to go between 7 and 9. They both have brackets, so it's equal to. Whenever it's a closed one like this, it's always less than or equal to. You could make it greater than or equal to, but then you have to flip everything, the numbers, and yeah, I didn't click it. Boop. less than equal to x less than equal to 9. Okay, now then we're looking for the graph. So the graph that has the brackets on both sides, there's only one of them. Next. So our interval notation is -3 to 7. Whenever it's two numbers, our x is between them. It's always less than. And neither of them's brackets, so it's just -3 is less than x, which is less than 7. So our graph, we're looking for two sets of parentheses at -3 and 7. So this one has parenthesis, parenthesis. So this is our answer. Parenthesis, bracket, 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 parenthesis. Okay. -9 to -3. So they want the inequality. That means x is between these. It's always less than. Neither of these are brackets, so it's -9 is less than x, which is less than -3. We're looking for the graph that has parenthesis, parenthesis. That's it. But -infinity to -6 with a bracket. So -infinity to -6 with a bracket. Since it's going to -infinity, first off, if you have infinity, you're going to have x. Then we figure out which sign. So if it's -infinity, it's less than. If it's positive infinity, it's greater than. And we have -6. This -6 has a bracket, so it has an equal to sign. X less than equal to -6. Oh, I have two less thans here. Oops. Get rid of that one. Okay, now then our graph is coming from -infinity, so these are the two graphs that are coming from -infinity, and we need the one with a bracket because ours is equal to. -infinity to -4. These are kind of really repetitive. Since it's -infinity, there's an infinity, so we have x. -infinity means it's less than. Then -4. But our -4 has a parenthesis. So that parenthesis means it's just less than. It's not equal to. So x is less than -4. There's a difference in them. So we're looking for the graph that comes from -infinity to -4. So we have these two. Our graph is not equal to, so it's the parenthesis. Because equal to means bracket. Okay. If x is greater than 10, then x subtract 10 is, this problem's on your test. At least it has been the last few times I've gave it. And this always throws people off for some reason. All they did on this problem is they moved 10 over to x. If we subtract or add on either side, the inequality does not change. The inequality changes when we multiply or divide, but we just subtracted 10 to the other side. So this sign is still the same, it's still greater than. Okay, this one they have x is greater than -5. And then they say then x plus 5 is blank. to 0. So if I move my 5 over to my x, because that's going to make this x plus 5 is greater than 0, because when we add and subtract, it does not change the inequality. So this inequality is greater than. Check. Okay, this one, we have 4x is greater than 20. Now when we divide by 4, we have x is greater than 5. If we want to check this real quick, because we divided, we can. 4 times 5 is 20. If you're checking a problem, you need to pick the number that's actually greater than it, not the same. Otherwise, it's an equal to, not an inequality. So a number greater than 5, we can say 10. So if we did 4 times 10, we'd have 40. Is 40 greater than 20? Yes. That's kind of confusing right now. But since we divided by a positive, nothing changed, because these are the same thing. We just divided each side by a positive 4. Okay. Did they not? Okay, it's fine. X plus 10 is less than 11. So the solution set in set builder notation is they want you to find the inequality, and the inequality is what we put into this spot, like type an inequality or compound inequality. The ones where we had 2 numbers on both sides are the compounds. So we're subtracting 10 right here. Since we just subtracted 10, sign's great. We have x is less than 11, subtract 10 is 1. This is what we put into set builder notation. So x is less than, I need 1. Oh, that's not an x from the bottom, y'all. I guess that's a multiplication sign. My bad. Don't click the x on the bottom. I got used to it and thought I could. Okay, so since x is less than 1, that means negative infinity to 1, because they're asking for interval notation, I should say that. And then this one is not equal to, so it's just a parenthesis. Equal to means bracket, and we do not have that. Click. So, parenthesis, negative infinity to 1, parenthesis, because it's not equal to. And then graph. So we're looking for the one that goes to negative infinity. So these two, these go to positive infinity. And then we need a parenthesis at 1 because ours is not equal to. Next. Negative 8x plus 8 is less than or equal to 24. So we're going to subtract our 8 because we're solving for x right now. Negative 8x, keep your sign, less than or equal to. 24 subtract 8 is 16. This is where these problems change. If you divide or multiply by a negative, like we have to do right here to solve for x, negative divided by a negative is a positive. But if you divide by a negative, you have to flip your sign. I'll show y'all why. 16 divided by negative 8 is negative 2. So now then x has to be greater than or equal to negative 2. If we wanted to check this, a number greater than negative 2 is what we need, so let's do 0, because 0 is greater than negative 2. If I put 0 into this, I'm going to do this one in blue. Check, and we're going to say x equals 0. So if I do negative 8 times 0 plus 8 is less than or equal to 24, because I'm putting this directly into this. But 0 is greater than negative 2. So negative 8 times 0 is 0, plus 8 is less than or equal to 24. Is 8 less than or equal to 24? Yes, this is true. Now let's say we didn't change our sign. I'm going to do this one in red. If I still had, put wrong over here as I do this. If I didn't change my sign and I had x is less than or equal to negative 2, a number less than negative 2 would be, let's use negative 5. So we're going to use negative 5. If I put this one into it, I would have negative 8 times negative 5 plus 8 is less than or equal to 24. Because I'm not changing anything about this equation they gave us. I'm just putting in a value that satisfies this inequality. This is the correct one though, but this is why. So if we do not change our inequality when we divide by a negative, the inequality no longer works because it's wrong. So a negative times a negative is a positive. 8 times 5 is 40. Then we're going to add 8 to this is less than or equal to 24. 40 plus 8 is 48. Is 48 less than or equal to 24? No. So the only answer that works on this is this one, because when you divide by a negative, you have to flip your inequality. X greater than or equal to negative 2. Okay, let's get rid of some of this extra stuff so that we can do the rest of it. Yeah. Okay, the solution set here, in interval notation, we're going to have a bracket because it's equal to, and it's going to go from negative 2 to positive infinity. Infinity always gets parentheses. Infinity. Can't click it. Get rid of infinity. Put a parenthesis with it. I'm struggling right now. Now then, we're going to find that graph. So we're looking for, look, they gave us 6. We're looking at the ones that go to positive infinity. So I have 1, 2, 3. This one would be all numbers. So we're only going to use that if, I'm sure we'll have a problem after we use that in a second. Okay, so we have positive infinity, and positive infinity. Our number was negative 2, so this one's positive 2, so it's gone. And then this one's a bracket, and this one's a parentheses. Ours was equal to. Check. Oh, 5x subtract 2 is greater than 18. So we're going to add 2. 5x is greater than 20. Then we divide by positive 5. 5 divided by 5 is 1. 20 divided by 5 is 4. So type your answer in interval notation. So this is our inequality that we solved. They want us to go straight to interval notation. So that means we're going to go to positive infinity. We're going to go from 4 to positive infinity. It wasn't equal to, so they both get parentheses. Never put a bracket with an infinity. I know I keep saying it, but it's necessary. Grab my infinity. Okay. Now then our graph, we're going to positive infinity, and we're starting at 4. And ours isn't equal to, it's a parenthesis. Next. 4x, I keep looking at the camera because I'm worried it's going to time out on me. Greater than or equal to 4 plus x. Okay. Same thing on this one. I like to keep my x positive because now then if it's negative, you have to remember to flip your inequality. So between 4x and x, the smaller one is 1x. I came back to this problem because I'm not sure when the timing stopped. I just wanted to talk about it real quick. So we went ahead and did subtract x, and we had 3x is greater than or equal to 6, and then we divided by 3. So we had x is greater than or equal to 2, and that's what we put right here. Then we had to change it to our interval notation. So I had 2 to infinity. Infinity always gets parentheses. Since it was equal to, we gave this a bracket. And then we looked at our graphs that went to positive infinity, and since ours was equal to, we grabbed our one that had the bracket. Oh, now let's go ahead and finish this lesson up. Boop. So this one's a closed compound. We have 0 is less than or equal to 3. X subtract 9, which is less than or equal to 9. Now, whenever we have a compound inequality, we're not getting like x alone on the side, we're getting x alone in the middle. So like earlier when we were writing them in interval notation, that's what we're doing. So first we're going to add 9. But when we do this, we have to add it to both sides. So we have 9 is less than or equal to 3x, which is less than or equal to 9 plus 9 is 18. Now then, it has to just be x in the middle, so the opposite of multiplying is division. So we're going to divide by 3 everywhere. So 3 divided by 3 is 1. 9 divided by 3 is 3, less than or equal to x, which is less than or equal to 18 divided by 3 is 6. This is going to go in our set notation. So I'm going to have 3 is less than or equal to x, which is less than or equal to 6. Our interval notation, we're going to have it from 3 to 6, and since they're both equal to, they both get brackets. Tab, and we're going to have bracket. Okay, now then we're looking for our graph that goes from 3 to 6 with 2 brackets. So that's -6 to +3. This is 3 to 6, but it's parenthesis bracket. This one's bracket, bracket. That's -6 to 3. Okay, last problem. -3 is less than 3x subtract 4 all over 4, which that's divided by 4, because the first thing we're going to do is move this 4. So the opposite of division is multiplication. So we're going to multiply by 4 on both sides. So -4 times 3 is -12. When I do 4 times this, it changes to 1. So I'm going to have less than 3x subtract 4, which is less than 0 times 4. 0 times anything is 0. Then we're going to add 4 to both sides, or all sides, however you want to say that. -12 plus 4 is going to give us a -8, which is less than 3x, which is less than 4. That's an ugly 4. Then we would divide by 3. So, those do not reduce more. It's going to be right in interval notation. Okay, so we're going to have -8 over 3, comma, 4 over 3. And since they're both just less thans, it gets parentheses. That's going to be what we type in there. If they had set builder, we'd have to do it with the x. We'd have to type in -8/3 x and 4/3. But this one, since I did that, it took it off. We typed just this in. Oh, parentheses. -8/3, comma, 4/3, close parenthesis. Ruh-roh. That ain't it. Just a second. Start over. Parenthesis. -8/3. click over, comma, 4/3. Get out of the denominator, close the parentheses. Okay. Man, that was fun. Okay. I'm going to go ahead and erase this. And I'll rewrite it right here. So we're looking for -8/3, comma 4/3. Now, this is like 1 1/3, so we're right at there. If this was 6, that would be -2, so this is -2 2/3. So we're getting close to those. Neither of them is going to be perfect, but we can go ahead and narrow this down right now because we just have parentheses. So, and we know that our number is between these two. They don't separate out. So no, no, no. We're looking at these right here, D, E, F, because our X is between -8/3 and 4/3. So let's see what we got here. We need one that's a little over 1 here. So these are a little over 1. This one goes all the way to almost 3, so E is out. And then this one has parentheses and this one has brackets, and ours has parentheses. Okay. Let me know if you have any questions on any of this. Send me an email. I will gladly help you. If you think I need to redo one of these, let me know that too. We'll get on it. Thanks, y'all.